All right, so I'm here to talk about doing reproducible performance testing of Suricata on a budget with TRex, um, especially at higher speeds. So my background, I've been mostly a software engineer. I occasionally dabble as a security researcher. I've been at ICEBRG now almost 3 years working with Suricata on our sensor. And then before that, I spent 9 years at Microsoft working on antivirus, doing a mix of security features, but also performance-related features in the AV product. So, kind of, what do I want to cover? First, I kind of want to explain, essentially, like, why is going to be setting up reproducible performance testing actually going to be useful. So we've had some interesting talks in the past about doing really high-speed Suricata or doing really reproducible Suricata with some Ixia devices, but we've not really seen a good way to kind of merge those two into something where we can do comprehensive testing. I want to go through some of the first approaches I took when I first started to getting some of this set up internally at ICEBRG. Then I kind of want to move on into talking about TRex, which is a package for doing exactly what this talk is about. I'll spend some time talking about how to use it, and then I'll go a little bit into kind of how far I could push it so far already, and finally I'll conclude, talk about some other ideas, talk about kind of how much it ended up costing, and see if there's any questions. So kind of why do we want to do reproducible performance testing? Well, I kind of break it up into 3 different things. So we want it to be reproducible. We want to kind of be able to have like traffic that's the same every time. So like when you're testing against your production traffic, depending on the time of day, the time of month, whether or not it's open enrollment, if you're a healthcare provider, you can have wildly differing both traffic profiles and traffic volumes. And it makes it really hard over time to kind of validate which features are making things better, which changes are making things worse. And it's hard to kind of do that. Kind of the second one is kind of on the performance aspect, it's when you're shipping a product out to a customer, you don't want any surprises. You don't want to be like, oh yeah, it can totally do 10 gigs, it shows up on their site and it's dropping all of their packets and they're looking at it and like, so why is this not working? So you kind of, when you have customers or you have a large fleet, you kind of want to know in advance what are the performance characteristics of the sensor before you deploy it. And you want to know like when you make a change, what will those performance characteristics change across your fleet rather than having to go test and monitor each thing in your fleet for each change. And then kind of finally, more generally, is the testing aspect. You don't want to be testing on your customers' sensors in production. You don't want them to have to essentially be your guinea pig when they're paying you money. So in that case, it's much better to be able to reproduce something very similar in-house that will allow you to kind of model their environment, but without having to risk their own production traffic. So kind of this talk was actually inspired by 2 different talks last year. The first one was everything you ever wanted to know about how configuration and rules impact Suricata performance by Brad from Proofpoint. And so that talk, he had about a 1 gigabyte Ixia traffic generator and set up the same traffic over and over again, and then just slightly tweaked a lot of different Suricata features to see kind of what would the changes do, like how does each thing impact Suricata. There were 2 kind of limitations that I noticed though. One is you need a very expensive device, and the other is it was still only at 1 gig, and the second talk, Septon 2, was doing 20 gigs. So how do we go kind of get this level of granularity and reproducibility, but do it at 20 gigs or higher without, well, breaking the bank? So the Ixia traffic generators that can handle 40 gigs and the Spirit, etc., all of these run $100,000 plus. At a startup like ICEBRG, I wasn't going to get budget for that. I think most of you also don't have the budget to go spend $100,000 just to test your sensors. So one of the reasons for this is these are much more powerful devices than what you typically need for testing something like Suricata or Bro. They can handle a lot of layer 2 stuff. They're designed to actually validate hardware, do a lot of malformed packets. So, and they have really nice GUIs, really easy to use, a lot of pre-packaged traffic for you to use. So they're really easy to use, but it's way more than what we need. So kind of my first attempt to try and be able to start validating our own sensors and be able to do it in a way where I could kind of know what the performance limitation was, so I could tell people, it's like, here's what we can do, don't promise more to our customers, please. That usually didn't stop them, because that's the nature of sales. But it was worth a try. So starting out, I used TCP Replay, and initially just kind of naively using it was a couple gigs a second. If you preload the PCAPs and run a couple in parallel, you can usually get 3-4 gigs a second, maybe close to 5, but you start running into problems when you do this. One is if the PCAPs you're using weren't actually originally recorded at the speed you're trying to reproduce, what you're doing is you're compressing those and transmitting them a lot faster than what they were originally transmitted. And what this means is normally when you have a couple milliseconds of latency, even on like the shortest hop on a network, where things coming in are not likely to get out of order, here it's much more likely packets start slipping out of order, or if you have like protocols like FTP, like you'll see the data transfer before the command, because it'll come in first, because it'll get on a worker that's less heavily loaded. So you get into all kinds of problems with the traffic coming out, and you start getting drops just happening on the TCP replay side as well. So this is really not ideal for reproducible testing, because it's not actually reproducible. So let's go faster. Let's see what we can do. So Cisco makes an open source package called TRex, and what TRex is designed to do is take commodity or not so commodity Cisco hardware, depending on how fast you want to go, and allow you to do a lot of the kind of more basic traffic generation tasks that you'd normally need a very expensive appliance to do. It supports up to 100 gig interfaces for any card that supports DPDK, so Intel, Napatech, several others. And kind of the big thing that's useful for us is it allows you to essentially take a given flow and randomize the source and destination and retransmit it each time with a different source and destination. So you don't have a flow manager where everything's getting hashed into one bucket because it's all just the same traffic over again. This is really useful because if you just replayed the one thing over and over and over again, one, it would start to pile on top of itself to get to these high speeds, but the other is you would never really use that much memory because it would always keep going into the same bucket in the same slot. Also, you would hammer one worker in a load balanced queue because it's going to hash to the same worker every time. So being able to do that is kind of critical. And then the other nice thing is for people who are doing IPS mode, it actually does do like latency and jitter tracking. It was originally designed for testing routers and DPI systems. So for IPS mode, it can actually test those things you're worried about, where packet loss, latency, jitter, that can negatively impact a customer network. So kind of what do you need to use to do this? First, you need the device you want to test. You need your SuriCata sensor, your Bro sensor, whatever. Next up, you need another server to actually act as the traffic generator. So this can be actually a fairly low-end server, but it's still going to need to have high-end NICs because it's going to be sending a lot of traffic. You need, as I mentioned, you're going to need those high-end NICs to handle 10 to 40 gigs of traffic at a time. And then finally, because of how TRex is set up, you actually need a switch or router that will sit between the traffic generation server and the sensor. And what this is doing is this is basically providing span support, but it does need to be a switch and not just a tap or packet aggregator, because what actually has to happen is these packets do in fact need to get routed from one interface to the other. So the way TRex works is it is actually simulating client server and is using two different interfaces. One pretends it's the client subnet, the other is the server subnet. So the hardware layout's actually pretty straightforward. As I mentioned, there's two connections between the traffic generator and the switch to simulate bidirectional traffic. And then you just run your standard span or monitoring port from the switch off to the device you want to test. And if you have more traffic than what you can fit on one link, then you need to load balance it and send it off to multiple interfaces or even multiple sensors if you want to test that configuration. So kind of for what I have set up, a lot of this was actually stuff we just kind of had laying around of servers we got, and then it turned out not to be the hardware, the configuration for what we actually wanted to ship out to anyone. And so I had some stuff to work with just around already. So for the sensor, it's a Dell 630. It's got a dual 2650 V4, so that's 12 by 2 cores, so 48 cores, and it's got Intel 520 NICs that take SFPs and run at 10 gigs. For the actual traffic generator, it's this old 730 we had laying around, has way too much RAM, has a dual 8-core CPUs, or sorry, dual 10-core CPUs, and again, Intel X520 network cards that we had a bunch of still just laying around that I could use. And then likewise, for a switch, I'm now using a borrowed Arista from our data center team that they had spare, because that's a lot nicer to work with. But we had just laying around that someone had eBayed previously that we didn't want in production anymore, an old Force 10, and that had the QFSP ports to handle up to 40 gig testing, so great. So pretty much almost all of this I could put together with just stuff we still just weren't using anymore. And then finally, you need the cables to attach all this together, which will become relevant later on when we get to higher speeds. So kind of to set up TRex, you go download the tarball from their website, you extract it, and then you go there, and the first thing you're going to do is you're going to want to run basically this command, and what this is going to do if there's no configuration on the box is it's going to go look around, identify all of the supported network interfaces on the machine, and kind of give you the address to go set them up. Kind of once you have that basic bit covered, then you want to set up the rest of the software. So you need to figure out which interfaces you're actually going to use. You need to go actually wire up the network topology. Then start setting things up. So you're going to want to actually set the interfaces up. Then you're going to want to go pick, like, what traffic do I want to test? Do I want to test a whole bunch of DNS? Do I want to test like a mix of kind of a bunch of things similar to kind of what I'm seeing in my current environment? Or do I want to just like hammer on one particular protocol? And then once you have the PCAPs collected, you set up the replay profile and you run. So for setting up the interfaces, it's etc TRex YAML. It's pretty straightforward. Mostly what you're trying to do is you're essentially identifying which interfaces are going to be used by TRex based on their PCI location. Something very important to remember is any interface you configure to this, when you run TRex, will be taken over by DPDK, and if you accidentally put your management interface on it, you're going into the lab and rebooting the machine to bring it back. So don't do that. So, but it's pretty straightforward. You just configure the interfaces, and then the port limit you need to set to make sure you're using all the interfaces. Kind of next up is the traffic profile setup. So there's a few different things here. You've got one entry for each PCAP. You also have the ability to kind of set the client and server ranges that you want kind of the packets to attempt to originate from and return from. And then finally, there's one other setting in here that matters, and that's CPS, and that's connections per second. And that's kind of how, if you have a bunch of different PCAPs and you want to weight them differently, like I'm doing here, then that would be how you set the effective weight relative to the other PCAPs in the traffic profile. And then finally, launching TRex is pretty straightforward once it's all set up. You just give it the traffic profile, you give it a multiplier, a duration, and you tell it whether or not you actually care about latency. And you tell it how many cores you want it to use. Multiplier is the kind of most interesting one here. Cores, mostly if it's not keeping up with how much you're doing, you want more. Multiplier, though, is really how you kind of determine the scale of how aggressively you're replaying your traffic profile. So that'll ramp up or down kind of how many connections it actually attempts of each PCAP in the traffic profile. And then finally, like if you don't want to go to all the trouble of setting up your own traffic profile, there's a ton already of different sample traffic profiles and associated PCAPs that just are part of the original TRex package that you can start playing with if you want. And a lot of them actually do come from other traffic generators' traffic, so you can go simulate them. So that's pretty much all you needed to do to get to 10 gigs, is just really straightforward, just set this thing up. There's documents. Some of the more recent ones are really good. Some of the older ones from when I first set this up were a little more challenging to get through, but there's still very good documentation. But now it's like we've got 10 gigs, can we go faster? So the setup for 20 gigs that I have is now 4 of the Intel X520 10 gig cards. SuriCata 4, I didn't get a chance to go up to 4.1 yet, sorry Victor, but still running Hyperscan 5, so, and then ET Pro running on PF-Ring 7.2, and with Bro 2.5. So I turned it on, I set to 20 gigs, the traffic starts flowing, everything's going great, and in 2 minutes the sensor is out of memory. And the killer is running around whacking processes left and right. So I turned off Bro. And then it's like, okay, now I'm just running SuriCata on PF-Ring. Very naive implementation. So I didn't do anything fancy. I didn't try and optimize core affinity. I just let it run. So this is kind of the output you're seeing from TRex. So it's actually tracking a bunch of different information about the amount of data it's sending, what errors it's seeing, what latency it's seeing. So you can kind of sit here and watch, and you'll, like when you first turn it on, it takes it about 20 seconds to come up to full speed as it starts sending more and more traffic, and then it's up and running and you can just walk away. This is kind of what the box running SuriCata looked like with 20 gigs of load on it. So as you see, a lot of usage. It's getting pretty close to the upper limit, but it's actually still got a little bit of headroom. And one interesting bit was if I actually go back, if you notice on the card is only on one NUMA node, and if you go look for on the second NUMA node, all of the physical workers are still getting similar amounts of work to do, but all of the hyper-threaded workers are the ones that are actually getting starved and not getting as much work because they're on a different NUMA node. So that was actually kind of interesting to see. Next up is, this is what the packet launcher looks like. It's just pegged every core it's been given, but otherwise that's it. So it's kind of running every core it has at full speed, and it's keeping up fine with what it's trying to do. So what I found, so at 20 gigs on a 24 core machine, SuriCata, with just a naive setup, SuriCata had no problem keeping up, and it was dropping almost no packets, and all of those were getting dropped actually at the NIC, so they weren't getting pulled out of the queue fast enough. As I mentioned, there was something weird with the hyper-threading on the second NUMA node, and then you probably only need a single core box for the traffic generator. So I was hoping to have something more interesting happen, but so far SuriCata is doing fine. So let's keep going. So 40 gigs. So I have a Intel XL710 NIC I installed in the packet launcher. I have a sensor now with 4 10 gig SFPs to handle all the traffic, and I had some cables for hooking all this up. And that's when I found out that the 40 gig Intel QFSP network cards are very, very specific about what cables they want. And unfortunately, because as Victor mentioned, this talk was accepted a little late, that cable is still on its way from China, because they had to go custom make it. So I did have a cable though where the Intel was willing to talk to itself, it just wouldn't talk to anything else with this cable. So I at least figured, okay, let's go at least see how is it going to work with TRex. And you can run TRex in loopback mode, and I think if I had an optical tap, I probably could have just used that instead of the switch setup, and it might have worked. But I didn't have a 40 gig optical tap laying around. So again, the Intel XL710, so the version with the QFSP instead of 4 SFPs. same packet launcher and with a working cable. What ended up happening is, because I was only using one interface and left the same core setting, it ran with only 4 cores and was fine. It could still send 40 gigs line rate back and forth across the cable without any problem. So probably we don't even need as many cores as what I thought from the last one. So that kind of brings me to some of the other ideas that I kind of had like coming out of this, which is there's a lot of other capabilities in TRex. So one of the things is they have a stateful version where it's actually keeping track of layer 7 state. So that's actually much more useful if you want to do IPS testing. You can actually keep track of what's going on and actually know when stuff's not making it through and know what's not making it through. The other neat thing I noticed is from when I last built this out 2 years ago, there's been a huge improvement to the management interfaces for it. So now you can write Python to manage it. You don't just need to write these text files. It's got SCAPI support, so if you've got something like FlowSynth that uses SCAPI to generate traffic, you can go wire that up to a Python script that's running this and just feed it traffic programmatically. And then kind of finally, the other thing that I think would be interesting to do, but started on last night but didn't quite get done, is automating, just taking a normal PCAP and splitting it out. So I forgot to mention, one thing is for PCAPs for this, each PCAP needs to be one kind of 5-tuple so that it can actually swap out one for one the client and server. So if you just have just a PCAP of like 100 different connections, you need to split that out to 100 PCAPs. And like for testing, where you've got just kind of a couple different traffic profiles or traffic types you want to do, it's not too bad. If you want to go take an hour's worth of production traffic from your system and put that in, that's going to be a lot of work. So it'd be a lot easier to automate that. Finally, kind of the interesting bit, how much did this end up costing? So it's like $450 for the NIC. You can eBay a switch for $1,000 or less that can handle this. I spec'd out a Dell that was actually way less than what was actually being used for traffic generation to something more appropriate, and that's like a $1,700 server, and you can probably get something equivalent for a lot less, and probably even don't need as many specs as what I have there. And then finally, you need to get the right cables. So fs.com is where I ended up going because they will make the custom cable that you end up needing for this. So overall, TRex is fantastic. It's free, and it works on commodity hardware. It's about $3,500 to set this up from scratch if you don't already have machines laying around that can do it. So that's a lot better than $100,000. And kind of my hope is, like, by introducing people to this will help improve collaboration between people, because they'll be able to pass and share traffic profiles and essentially work against the exact same data, so that when they're working on trying to figure out performance issues, they can all be working on it instead of trying to keep finding people with enough production data to really make SuriCata have to work hard. And so here's kind of the links to the instructions and how-tos. And that's it.